Okay guys, so there's a video explaining many of these, right? So I'm making a second video here explaining a couple more. This one was not explained on the first video. So let's look at this. And the instructions tell us to write an equation and its condition. Write a function and its condition, right? Now this is a piece of a line. Normally a line goes to the left forever and to the right forever, but notice that there's no arrow on this side. So what we need to do is define what that piece of line is. So let's first find out what the M is and what the B is, because after all, in order to write an equation in slope-intercept form, we have to write it with the M and with the B. So looking at this line, it does rise 1, run 3. Rise 1, run 3. So the slope is 1/3, and the B value you could clearly see is 1. So our equation, our function, you can label it f of x, g of x, I'm just calling it y, is equal to 1/3 x plus 1. Okay, that's my function. But you see the function y equals 1/3 x plus 1, it crosses here, goes up 1 over 3. It goes this way forever and this way forever. And we obviously know that this is not the case, that it goes to the left and to the right forever. So I need to give it a condition. So what is the condition on the instructions? It says that the condition is the domain of what you see. So we need to give it a condition. We're going to say if your x values are, and this is how to do the domain. Look at your x values. X's run from left to right. So does this thing go to the left forever? Yes, because the arrow is saying that it goes to the left forever. Does it go to the right forever? No, it stops right here. That's an endpoint. So in a sense, it starts at this x value of 3 and it goes to the left forever. So how do we say that it starts at 3 and it goes to the left forever? X is less than or equal to 3. Again, it's an or equal to because it is a solid dot. That's why you need a solid line underneath that inequality. Now, in addition to this, I mean, this is the most important part of the lesson. But in addition to that, I also say state the range, because the condition was a domain. Might as well continue practicing the range. And the range are your y values, the up and down, not the left and right. The domain are the x, which is left and right. The range are the y values, which is up and down. So does this graph exist up and down forever? No. If it did, you would say y equals all real numbers. But as you could see, it does go to the left forever and down. It continues to go down, so it does go down forever, but it doesn't go up forever. So when we're thinking about the y values, this is the highest point right there, which is obviously the value of 2. I mean, this graph is at 2 and below. So how do we say that the y values are at 2 and below? We're going to say y is less than or equal to 2. So this is the additional bit of information. On the quiz we will have both state the function and its condition, which is a domain, and some questions will be just state the range, which are the y values. Jumping to this one, see, they're all pretty easy because what you need to do is state the function, which means you need an m and a b. Could somebody tell me the m value? 2, that's right, because from left to right, you're going up 2 over 1. Up 2 over 1. So we know that the m is up 2 over 1, so you could just say m is 2. The b value happens to be what? Where does it cross? At -1. Perfect. So that means that our equation is simply y equals 2x minus 1, and the condition if, this is where the domain comes in. The domain are your x values, and the x values run left and right. So does this line exist to the left forever? No, it doesn't exist at -3 or -4, right? I mean, it would if the line kept going, but it doesn't. It's an endpoint right there, open dot endpoint. So where does it start existing in terms of x? At -1, right? And where does it exist? To the left, which would be less, or to the right, which would be greater? Greater, right? I hope we all see that -1, that's where that x value is at, and it starts existing from there, and it goes that way, to the right, which means greater. Maybe I shouldn't draw all these arrows, it might confuse you. But the bottom line is, yes, the domain is, the condition is x has to be greater than negative 1. Not greater than or equal to, because it was not a solid dot. This is an open dot. That's why it's just greater than negative 1. So the condition is always going to be the domain. The domain are always your x values. The x values always run left to right. So you got to ask yourself, does it go to the left? Does it go to the right? Or maybe it's between this value and that value, and that's when you put the x in between those two values with the less than symbols. And we'll get to those in a bit. But then before moving on, the range values are very important. Those are the y values. So what is the range of this one? Anybody? We're going to say, does this thing run up forever? Absolutely. Does it go down forever? No, it has an endpoint. So where are your y values at? At what point does it start existing on the y's? At negative 3, okay? And does it go up or does it go down from that negative 3? It goes up from that negative 3. So how do we say the y value that are above negative 3? We say y is greater than negative 3. And once again, notice open dot means that there's no solid line underneath it. If it would have been a solid dot, I'd put a solid line underneath it. So again, the domain are your x values, which are left and right. The range are your y values, which are up and down. I also usually put this like in a little cloud on the solutions. I put the range in a cloud. Anyway, how about that guy? Could anybody give me any useful information about this graph?
The amp is 1/2.
Thank you so much. And what else?
And the b is equal to.
So right here, guys, we know that we're talking about a piece of a line, right? Now, I know I already wrote down b equals negative 1. What you have to do is imagine what the rest of the line looks like. So we're going to just briefly, I'll erase it in a bit, but just briefly, I am going to see that the rise is up 1 over 2. We already said that. So if I continue to go up 1 over 2, I'll end up right here. And this is where the line would continue, right? Continues with the arrow that way. Normally, the equation y equals 1/2 x minus 1, that would be this yellow line going left and right forever. Isn't that right? Okay, so you need to imagine where the line would go. Where's the entire line at? That way you could see your b value. Okay. Now, yes, it's true you could have written in point slope form because you have a slope and you have some points and do all that algebra, but I mean, I think it's a lot easier to just draw that line, that dotted yellow line, or not even drawing. I mean, because, yeah, drawing, you don't want to make everything all messy. But the fact is this: if you see that your slope is up 1 over 2, and you just keep going, up 1 over 2, boom, there's your b value, right? So you know your m, you know your b, that means you know your equation, your function. Now, how about its condition, the domain value? That's absolutely right. X is less than negative 2. So that's the condition. You're going to put if x is less than negative 2. Again, the condition is the domain. The domain are your x's. The x's, obviously the x-axis runs left and right. So this thing, does it go left forever? Yes. Does it go right forever? No. Right? It actually has an endpoint right here. And this endpoint, this x value is negative 2. Okay, it's right there. And where is it going from this value? Does it go to the left or does it go to the right? It goes to the left, which means less than. That's why it's less than negative 2. Once again, if that would have been a solid dot, it would be a less than or equal to, but it's not. So we have the function, we have its condition. Now let's state the range. The range are your y values. And since we're only looking at this piece of the line y equals 1/2 x minus 1, what y value is it at, and is it above that y value or below that y value?
It's y is less than negative 2.
Thank you so much, Daniel. Y is less than negative 2. That is the range. Okay, so moving on to this one right here. What function? Actually, this is not even a function. The equation of this guy. So it's not even a function because it's a relation only, but the equation of this guy would be x equals 2, because it's a vertical line crossing the x-axis at 2. The condition is the domain, so you would say if x equals 2, because that's the only value on x. And what about the range? The range is what? Y equals all real numbers. Why? Because it goes up forever, it goes down forever. You guys want to see this one or no? Okay. So on this one, give me some information. What's useful? What is the slope? Negative 1/2. Thank you so much. What else? The b value. Negative 5. Okay. How do I know that? Down 1 over 2. Down 1 over 2. There is an arrow. That technically means that it does cross that way forever. So, I mean, the b value is negative 5. So that means my equation is y equals negative 1/2 x minus 5. The condition, the domain, which means left and right. Does this thing go to the left forever? Does it go to the right forever? Yeah, so we know it goes to the right. We know it's going to be a greater than symbol. But what value does it start at? X is what? Greater than what? Negative 4, right? So x is greater than negative 4. If x is greater than negative 4. Now for the range are your y values. Does this thing, the y goes up and down, right? 1, 2, 3, 4, 5, negative 1, negative 2, it goes up and down. Does this thing go up forever? No. Heck no. It doesn't exist anywhere up here or over here. Actually, it doesn't even exist over here at negative 1 on the y. It starts existing at the y value of negative 3. It starts existing at the y value of negative 3. And does it go up or down from there? Goes down, which means what? Greater than or less than? Less than. So your range is y has to be less than negative 3. Why is it not less than or equal to? Because it's not a solid dot. So jumping around, let's go to the second to last one. And again, let's state the entire line equation. What is the entire line equation? Well, to state the entire line equation, you need an m and you need a b. The m is obviously what? Down 1 over 3. That is your slope. Negative 1 over 3. Where does it cross the y-axis? I know that you don't see it cross the y-axis. That's like you seeing my arm and not seeing my head. But you know where my head's at based on my arm. Okay? So that might sound weird to people on the video because they didn't see what I was explaining. But anyway, it goes down 1 over 3. If I continue down 1 over 3, oh, this is hard. Because you end up over here.
It crosses the y, so it's not at one specific.
Yeah, not a specific value. It would cross at 2/3, right? 2/3 of the way down, so it'd be negative 2 2/3. Dang, that's horrible. So this one's going to be a weird one because it does cross at negative 2 2/3, right? Negative 1, negative 2 2/3 of the way down. I will not give this to you on the quiz. Don't worry. So your equation's y equals negative 1/3 x minus 2 2/3. Now you need a condition if, and the condition, you're only looking at the x value going to the left, which would be less than. So right here it's negative 2. To the left, it'd be less than negative 2. So the condition is if x is less than negative 2. Let me erase this blue part. Starts at negative 2, goes to the left. So there's your entire function. I will not give you that type of question on the quiz. I hope not. If I do, I'll delete it. Don't worry. And the how about the range? What's the range right here? Y is what? Negative 2 greater than. So y is greater than negative 2. Why? Because the y values are up and down. This thing obviously starts at that low value of -2 and it goes up forever, up and to the left forever. So you'd say y is greater than -2. All right, let's move on to this guy over here. Give me some useful information, anybody? The slope is 1 over 2. We got that by just going up 1 over 2 from left to right, up 1 over 2. So slope is 1 over 2. Now, again, we are looking at a piece of a line. So I am going to extend this, even though it's not really extended. We're only looking at the piece, but I'm going to extend it with that pattern of up 1 over 2, but backwards to see what my b value would be. Over 2, down 1, over 2, down 1. I know that the entire line really does cross the y-axis at 3. So the b value is 3. I mean, if it makes you feel better, go ahead and draw it, right? But we know that we're not looking at those yellow pieces. We're only looking at it from here to here. You know what? Maybe I could do this. Watch this. That's not it. Watch this. If I could get this to work. That is the piece that we're looking at. Now, what is the equation? The equation is y equals 1/2 x plus 3. And what is the piece of that equation that we're looking at? Here's the condition, the if part. If what? This is obviously the x value of 2. This is the x value of 4. So, and we're only looking at the piece between 2 and 4. So we put the 2 and the 4, and we put the x in between the 2 and the 4. And then we put less than symbols. And because both of these dots are open, we do not put solid lines underneath it. And that's it, right? We only looked at the piece of that yellow line, which is in red, okay? I hope that helps. Let me delete these yellow pieces. What is the range? This is a little bit more challenging. Range are your y values. Check this out, guys. If I focus in from that y value to that y value, what are we looking at? What are the y values when you talk about range? Range, it's 4 and 5, right? This y value is 4 and this y value up here is 5. This entire red piece is from the y value of 4 up to the y value of 5. It doesn't go higher, it doesn't go lower. It's between 4 and 5. So you have to put your smaller number on the left side, the 4, the bigger number on the right side, the 5, with your y in the middle with less than symbols. Now, if you had solid dots, you'd put less than or equal to, but there's your range. Y is less than 4, which is less than y, which is less than 5. It's a compound inequality. I don't know if those boxes are helping you or confusing you. I hope it's helping you. So let's jump around to this, go to this question right here. In order for you to state the function and the condition, you got to first identify what the function is by identifying the m and the b. So could somebody tell me the m? What's the slope? Negative 3 over 2. Excellent. What's the b value? -3. Now, if some of you are thinking, wait a minute, this thing does not cross the y-axis, how could we know that the b value is -3? Remember, we're looking at a piece of a line, okay? What is that line? If you wanted to extend it, you could draw it out. You could go that way and that way forever, but we know that it doesn't have the arrows. It's only a piece of the line, which is why they don't show it. But nevertheless, we are watching a piece of the line y equals -3 halves x minus 3. So the function is y equals -3 halves x minus 3. And the condition's always the domain, and the domain is always how it's running left and right. So if it actually ran to the left forever and to the right forever, you would say x equals all real numbers. But there are no arrows going to the left, there are no arrows going to the right. It's strictly between here, this x value, and that x value. So what are those two x values? I want to actually just put a little green dot right there and right there. Those two x values are -4 and -2. So since you know that it's not going to the left forever, that would be x is less than. It's not going to the right forever, that'd be x is greater than. It's between the -4 and the -2. We're going to put -4, -2, and we're going to put the x in between them because the area of this graph is in between the -4 and the -2. And of course we put less than symbols always, and since they're solid dots, we're going to put a solid line underneath those inequalities, and that is the function with its condition. In addition to that, we want to practice stating the range. The range are your y values. Now this one's slightly more confusing because when you look at the y's, you're looking at how this graph goes up or down. So for example, if I had an endpoint, I do have an endpoint here, but let's say I had an arrow going down forever, then you would say y is less than 3. If you had a solid dot here with an arrow going up forever, then you would say y is greater than, I should have said greater than or equal to because they're solid dots, so greater than or equal to 0 if it were going up forever. But we know it's not going up forever, it's not going down forever. It's actually in between this y value, which is 3, and this y value, which is 0. So the range should be your smaller value on the left side, which is 0, your greater number on the right side, which is 3, with the y right in between them, and the less than symbols. And since they're both solid dots, you put solid lines underneath it. Let's continue. Let's jump to, why not? Let's do this one right here. Could somebody please tell me something important about this graph? Any information's good. It's array, okay, but so it's a piece of a line, which, yeah, we're looking at array here with an open dot, but
M goes -3 over 2.
There you go. The m is -3 over 2. That's perfect. That's a very important bit of information.
And then the B value would be 2.
The b value would be 2, right? And of course, we need to extend the line sometimes to see where it crosses the b value. Now, again, why do I want the m and the b? Because that's what I need to write an equation in slope-intercept form. One option is to get the slope. How do I get the slope? Looking at the line from left to right. It's obviously going down from this point to that point. It's going down 1, 2, 3 over 2. That's why the slope is -3/2. If I really wanted to, I could take the slope, -3/2, and I could take the point 2, -1, and write it in point slope form, then change it. But why the heck would you want to do all that work, right? All you have to do is extend the line according to the slope down 3 over 2, but backwards, over 2, up 3, over 2, up 1, 2, 3, and you'll see that the b value is 2. So we could have done it the old school way of finding the slope and then using the point 2, -1, and do it in point slope form, then changing it, but it's a lot easier to extend the line and see the y equals mx plus b equation. So my equation is y equals -3/2 x plus 2, and again, we are not looking at the entire line. I want just a piece of the line. What part of the line are we looking at? We're going to show that with the condition that your x values have to be what? Is it going to the left forever, or is it going to the right forever? To the left. From what x value?
4.
From the x value of 4, right? I mean, this whole graph does not exist at 5. It starts existing right here, and that x value is 4. And it's to the left, which is a less than. So x is less than 4. I hope we're starting to understand this, guys. How about the range? The range are your y values. Now, the y values run up and down, not left and right. So the question is, does this go up forever? Does it go down forever from a certain point? Or is it between two values of y? So you tell me, does it go up forever, down forever from a certain point? Or is it between two values of y? Up forever from what's the lowest y value? -4, right? So from -4 up. So how do we say that it has to be above -4? You're going to say y is above -4. Now remember, your condition is your domain. Now if I did ask you what's the domain of this, you would say the same thing, x is less than 4, right? Too easy. Could somebody just tell me the equation of this line already? Y equals what? 1/2 x plus 2. Exactly. The slope is 1/2. The b value, you could clearly see that it crosses right there at 2. Now what's the condition? If, what's our domain going to be? Is it to the left forever from a certain value, which is x is less than? Is it to the right forever from a certain value, which is x is greater than? Less than, because it's going to the left. What x value? 4. Cool? I mean, that's pretty much it right there. Now, how about the range? The range of your y values is the y above a certain value, which would be greater than, y is greater than a certain value, or is it below a certain value, which is y is less than that certain value, or is it between two y values, which would be a compound inequality with the y in the middle? It's less than, it's below, and what y value is it below? Y is below 4, y is less than 4. As you could see, the y value is at 4 right there, and the graph is below, right? It's below. Maybe I shouldn't draw all that again. Sorry. So, what about this last one? Anybody? Slope would be 1/2. How do we know? Because from left to right, it's going up 1 over 2. All right. The b value will be 5. Now, if you're thinking, wait, it doesn't cross the y-axis. No, it doesn't. Not on the piece that we're looking at. But this is a piece of the entire line, which continues to go up 1 over 2, up 1 over 2, which would be right there. So you could draw it, or you could just continue with the pattern, just so you could see where it would cross, so you could get the b value of 5. Now, once you have your equation, y equals 1/2 x plus 5, the condition would be the domain. Is it going to the left forever, which is x is less than? Is it going to the right forever, which is x is greater than? Or is it between two x values, which you do a compound inequality with the x in the middle? Less than, because it's going to the left. So I want to say if x is less than what? -2. That's exactly right. Here is your beginning point, and it's going to the left. Now, what is this x value? It's -2, and it's going to the left. So x is less than -2. If this would have been a solid dot, I'd put a solid line underneath my inequality. Anyway, there's my answer for the range. We're going to put y equals, actually y equals, why did I say y equals? Is it above a certain value? Is it below a certain value? Now, if it were going up and down forever, you would say y equals all real numbers. It's below a certain value, so we're going to say less than. What is that y value? 4. So this is the majority of, this is the biggest part of the quiz tomorrow. Looking at a graph, stating its function and its condition. Now, on this particular video that I'm recording right now, I explained all the other questions. There was already one video posted which has the other ones explained.